I'm giving my students an exam on resonance structures this week, so I figured that I'd make a video and help anyone who's taking organic chemistry right now also be able to be successful with creating resonance structures. There are some patterns that you're going to look for that'll help you predict when you're able to move electrons to create these resonance structures. The first pattern you're going to look for is an allylic lone pair. The allylic lone pair is any group that is adjacent to an alkene. In this example, we have an oxygen that has two lone pairs and it is in the allylic position because it's coming off of the alkene. And so we're going to have two arrows in this example. We're going to have one arrow that shows the pi bond becoming a lone pair, and then a second arrow showing a lone pair becoming a pi bond. It's almost like an exchange. That way, after the movement, we have the formation of a lone pair on the carbon, which now is a negative charge, and then we have the formation of a pi bond between the carbon and then the oxygen. The oxygen has 3 bonds, so it's going to have a positive charge as a result. Moving to our next pattern, we are going to see an allylic positive charge. So now looking for a positive charge that is adjacent to an alkene. We have one positive charge that is adjacent to our alkene here, and so we are going to have one arrow that shows the movement of electrons. This arrow is going to show that the pi bond is going to basically rotate, and it's going to rotate towards the positive charge. And so now we have the pi bond on the end point, and then where the carbon lost the pi bond, that is going to be the positive charge now. Our third pattern is going to be a lone pair adjacent to a positive charge. So this is where you do not need to have an alkene. You just need to have a pi bond, a lone pair that is adjacent to the positive charge. And so there is going to be one arrow for this type of pattern, where that lone pair of electrons is going to then form a pi bond between that atom and then whatever atom has the positive charge. And then so after that lone pair forms the pi bond, we can see that there's no longer a positive charge on the carbon, but then once that nitrogen has 4 bonds, it will then have the positive charge. Our last pattern is going to be a pi bond between atoms of differing electronegativity. We are going to see this with a lot of our functional groups. We are going to see this, for this example, in acetone. We have that ketone there. We have the pi bond that is between the carbon and the oxygen. Oxygen is more electronegative, so it wants those electrons. Those pi electrons will go to the more electronegative atom, then leaving the less electronegative atom with a positive charge, and then oxygen in this case will then have a negative charge because it gained an additional pair. These are just quick patterns to look for when you are thinking about how can I draw resonance. These are the 4 that you are going to see most often.